Integral calculus, definite integrals. Up to this stage we've been doing indefinite integrals where we have to include a constant c at the end of every integral. Now we're going to look at what's called the fundamental theorem of calculus. If f of x is continuous on the interval a to b, no breaks, and if f of x, uppercase f of x, is any indefinite integral of f of x, so therefore that is equal to the integral of f of x dx, then the integral from a to b of f of x dx is equal to, that's the integral from a to b, but now we've integrated it, so we no longer have the integral sign, and that's equal to substitute b, substitute a, and subtract. Let's do an example. The integral from 2 to 3 of 3x squared minus 12x to the negative 2. Well, pretty straightforward to integrate. X cubed plus 12x to the minus 1. That c is sort of faded because there's no c really, because have a look here, f of b minus f of a, that has the c and that has the c, so the c is gone. So therefore we're just going to have that, and we're going to substitute 3 into there and 2 into there and subtract, and that gives us our definite integral 17. Trigonometric functions, so the integral from negative pi by 2 to pi by 4 of sine x minus cos x dx. Just check that it's continuous on that interval, and it is. Sine x and cos x are never undefined per se, so therefore on any interval they are fine, but not if they're dividing, because then you cannot have 0. So we're going to integrate. The integral of sine x is minus cos, and the integral of cos is sine. So there we are. So now we've integrated, but it's still from minus pi by 2 to pi by 4. Now we're going to do our substitution. There we have it. Another example, bringing in logarithmic and exponential functions. First check that f of x is continuous from a to b, from negative 1 to 1. That's fine, but this hits a problem. You cannot divide by 0. So therefore it's not continuous on negative 1 to 1. Now that being the case, what we would do usually is we'd find the integral from negative 1 to 0 and then 0 to 1 in order to be able to do it. So now, here we are. We have it again, but now we're going from 1 to 2, and both of those are continuous on that interval. In order to integrate this was covered in the previous video where we integrate by inspection. So we say, well, what differentiated to give us this? Well, I know it had to have an e to the 4x, so therefore we'll let it be ke to the 4x. Now we'll differentiate it using chain rule, remember, because the inside function is 4x, thus the 4. And we get 4ke to the 4x, and we equate it to the function we want, which means 4k is 5, k is 5 over 4. So therefore we have a 5 over 4 there, and that's the integral. The integral of 1 over x is ln x, so the integral of 4 over x is 4 ln x. can substitute, and that gives us our answer, correct to 1 decimal place. You may find it interesting to investigate on your calculator. Many calculators nowadays have the integration, the definite integral, and you can check it on your calculator. Just note that in an examination or test, you'll be required to show workings, so it's no good just giving the answer. But it's a good way to check in an exam. Some exercises for you to do. Number 1, a straightforward integral. There we are, like that. Substitute, and we get 4. Number 2, separate into 2 separate fractions. But hang on, not continuous. Yes, you cannot have x equal to 0. So it's straight out. Number 3, same thing, but now from 1 to 3, so we can separate into 2 separate fractions. Pretty standard integration, substitute, and we get our result. If you go from there to there in an exam, that's fine. Obviously, you're going to use your calculator to do that. You're not being examined on that mechanical arithmetic. This next one is continuous, so we're going to write that as 2x to the half. And pretty standard integrals. Number 5, yes, continuous. Notice that e to the minus x integrates to minus e to the minus x, because when you differentiate, you're going to have the inside function negative x, which is going to introduce the negative, changing this to a plus. Sine 2x. Remember that you have to allow for the fact it's 2x, that's what that half is doing there. I can separate out into 2 fractions. It is continuous. Integral of 1 over x is ln x. Tan undefined at pi by 2 plus k pi. That's fine there. That's first quadrant, so that should be acceptable. Yes, continuous. Multiply out, pretty standard. There we have it.